compost here at Thule Ponds at Tyson's Lagoon. One of the things that we're going to learn, if you haven't been here before, this is Tyson's Lagoon right here. It's the big pond. It's a 5-acre pond. And then these are what we call constructed wetlands. These were created by Alameda County Flood Control. And when we first got this place, there was absolutely very few trees. There was no soil cover. And as we all know, hopefully, soil is important for growing things. So let's take a look. This picture here is a little video from this area called the seasonal wetland, right in the upper left-hand corner of the picture. So let's take a look at what we do. This is a seasonal wetland in the north side of Thule Ponds. This is where floodwaters will come, fill up, and then go out to the Maui Slough via these large outflow pipes, storm drains. Now, as you can see, what we try to do is to make sure that the sediment doesn't create a jam later on, making gravity not work. We pile up the top of the soil, which, if you notice, is dark. That's because it's somewhat hydritic, which means that it so that's why there was no trees on this area, because this area here that we just looked at is flooded all year round, or not all year round. It's seasonal, so only during the stormy. So none of the big trees can actually grow. So we're going to look, and this is what we're going to do today. We're going to look at the soil at Thule Ponds. We're going to learn how to describe soil, because soil is not created equal. There's different soils from different parts of the local area, and from the state, and from around the country. They're all different soils, and soils are important not only to Thule Ponds but for growing, but not all plants have the same requirements. We're going to look at the two soils that we have here at Thule Ponds. We're going to look at the importance of soil, and we're going to look at some soil activities you can do at home. Then after we finish this part, because it's vital for you guys to understand that compost just helps soil get better. It is not soil itself. So we're going to take a look at what soil is. First, we have to learn how to describe it. Now, soil is not just dark. It's not just any one color, because soil, as we're going to learn, is crushed rock plus organic matter. That's where the compost part comes in. And the texture has to do with how large the pieces of the rock are. If you look at this little picture here, we'll see that gravel, sand is smaller particles than gravel, and then mud is even finer grain. That means they're smaller. And then you have clay mud. You could always tell clay mud because it always kind of sticks together, and it's the mud that your parents don't like you to get in because it gets stuck in the fabric and hard to get out. So these are going to be the beginnings of our soil. So it's important to understand size, and we'll learn a little bit about that. Then we're going to learn describing soil. You got to say how much organic matter is in there. And organic matter would be other leaves, would be twigs. It would be things that get that were once living that gets mixed in with the crushed rock. We also, when we describe soil, have to understand if there's water in there or how much airspace. But it could be dried soil or compacted without air, and it's still soil. So it depends on the water and the air to see how important it's going to be for especially agriculture, growing things. Color is going to be something that we're going to look at, and it's going to mainly reflect the type of bedrock or the rocks that it is part of. So we're going to see in Hawaii, you would have red soil, because it has a lot of iron in it. And so it depends on what that bedrock or the rock, and we all know rocks come in many, many colors. And we're going to look at what it's composed of. So let's take a look at what really, I want to make sure you understand this before we go on. Soil is not just the word dirt. Dirt is just a word that we use
to describe something that's dirty. Some people refer to it as soil, but soil itself is a scientific term, and it is crushed rocks plus organic matter. So that's these two, organic matter in the form of compost or other things that we're living. Now, want to make sure you understand this. Rocks are made up of minerals. Minerals are made of elements. It's these elements that when it mixes and erodes out, that the plants will need. And so that's why sometimes you'll see plants coming right out of rocks, because if the plants can get right to these elements, then a lot of times they can grow. Elements and compounds are needed for life. So there's things like, that's why when things grow from the soil, it needs water. In some places it needs the oxygen, it needs the carbon dioxide and much more, not for the plants, but for the other little organisms, because that's what we're going to learn about when we learn about compost. It's that compost where the living things are, and it is those animals that start breaking down the organic matter and sometimes the soil or the crushed rocks to get the animals and the plants to use these elements and compounds. So it really is more scientific than you thought. Now, let's take a look at tulipans again. This is an aerial view. This is Tyson's Lagoon right in between. The red represents the Hayward Fault. So this is where it's actually moving because of the earthquake fault. But so that's why we have, we talked about that in one of our earlier ones. These are ponds C, B, and A. Now notice, this is a picture of the soil over here on the Hayward Fault side, and this is on the east side. Now notice, this almost looks like rocks because it mainly was a lot of broken up rocks. When we first got this place, there was no soil breaking. This was the soil. It was real dry. It was very difficult to grow anything. Down here is where we have the hydritic. It has a lot of organic matter, but because it's underwater most of the time, if you ever notice, trees don't usually grow in a body of water. So these are the two types of soil we have here at tulipans. Now, that's the surface. On the surface, that's it. But when you go down, and you can go down 30 inches, 48 inches. This is what we call a soil profile. And soil scientists, and yes, there are scientists, and actually they're very valuable and they're very needed. It's a good job. Because soil grows things, and you need soil scientists to understand what's going on. So if you notice this profile here, this is where all the organic matter is. And this is where we're going to find most of the organisms when we talk about the composting, because a lot of animals need air, and that they're going to have to get that from the atmosphere. As you go down you have these different horizons. You have A, which is what we call topsoil. B, which we call subsoil. It has some organic matter, but it has more of the parent material, which would be the rock. And then C would be mostly the parent material being broken down by water and all these other effects going on it. And then underneath here, we call it R. It's just rocks underneath it. So let's look at some other profiles, because we're going to look at a really little profile of tulipans. Soils can be described by many different things. And so like as you're going down, we would describe, and think about how you would describe this. This one here on the left is dark. And then as it goes down, look, notice it has a lot of rocks in it. So it has more rocks than it has organic matter. And then as you go down here, this would be almost your rock, your bedrock. And then if you go to the one on the right, you'll notice that they're more fine-grained. And that's probably because there was more water here and it eroded more. And as you can see here, you're going down from more clays as you're going up to the topsoil. So, but the richest layer is always on the top. Now also notice that minerals can be described by the mineral that it has in it, or the crushed rock, the color, the particle size, and minerals that are magnetic. And Debbie will talk about that later on when we see how can soil be magnetic. Well, we're going to find out that it can. Now this is Just the other day, I was looking at some old records and I found this wonderful log from 1912. So this is over 100 years old, these pieces of paper. And it talked about a rock log at Tulipan's. Somebody from the California Nursery, which is a place that we're working at, had somebody went and took a core. So this is a little core. So this is, if you can see, this is lighter than this one here. This one is the hydritic soil. So this is the one that's on the side of the earthquake fault. And this is the side of where the ponds are, pond A, B, and C. But it was so interesting to look at that they dug all the way down just to see what the soil was. What were they looking for? They were trying to figure out if there was water down there and if they could get the water, or would it be just a good place to grow things? And it was neither. Now, so this is our how scientists actually look at it, and how when they go in the field, they then take it back to do more tests on it. So this is, I found this in our archives. This is from the 1970s. This is a soil scientist, Kay Berstrom. And what she did was she took little specimens at different inches. And then she'd go and compare the different types. And then she would make a soil profile in the whole area. It's actually kind of complicated, but they can actually look at below how the soil has evolved through time. Now look at over here. This is what you can do. A soil scientist would do like this, but students can also get a different soil when you walk around. What we have the kids do, you can get a popsicle stick. You can get a little jar and make some mud out of the soil, and then just rub it onto the soil and say where you got it. And then you can compare it and contrast it. And then this is how you can start learning that there's lots and lots of different soil all around. So now we're going to go to...
Hi everybody, it's Debbie. I'm back here in North Carolina. Just wanted you to get an idea again of Lake Norman that's behind me. This is the Catawba River that is dammed up along the way. It's also our watershed for our drinking water. Storm water goes in here. You'll see we've got some people out there goofing around on a pontoon with a tube. And then this is Pickles that's going to go get the stick for us. Now it has rained the last couple days and it's been colder than normal, so a little bit chilly. I'm gonna go over here. The water's come up. It was below. You could see the sand and all here, but now it is hiding under the water. So come on over, see if you can get a look and how clear the water is though. Can you still see the sand under there? All right, again, if you look along the rocks here, these are granite rocks. So that's our parent material. That erodes over time. It's broken apart into smaller pieces. That again is our parent rock, gives us our sand. We've got our red mud and all underneath here as well. I'm just gonna put my, hi Pickles, are you helping? Okay. I'm gonna get a little bit of shovel full of sand here, mud, dirt, see what we can find. And I'm just gonna put it right up here. Pickles, what do you think, Pickles?
Okay, so Debbie has just taken some mud out of the lake. Now remember, this is not soil. We're looking at how soil is being made. And so the mother rock was, or the parent rock, she used the word, you could use either mother rock, parent rock, or just rock. It was granite. And now it's breaking apart. So let's look at what she found.
Hi everybody. All right, we've got our shovel full of soil here. Let's take a look and see what we've really got. Let's see, it looks like lots of sand particles. Again, I've got some of the pieces of granite that have eroded away. That would be fun to look at with a microscope. So I see a lot of sand here. Now, if I make a patty cake, kind of a big ball, that's another thing about the texture of this. It's got enough moisture in it, of course, it's going to stay in a ball. It does fall apart some, breaks apart. So there is a lot of air still in there, again, between the grains of sand and all. Let's keep digging. Oh, look, here's a clam. Pickles thinks it's a treat, something she wants. Here, Pickles, let's rinse this off. There we go. So that's a sign that we've got some organic material. So we do have some plants and some animals here. Right along the edge here, you do see we got small little plants that are in there. I'm gonna keep digging through this and see. Oh, here's another clam. Now, if I can't open it, that means the animal is still in there and I'd throw it right back. But no, this one's already gone there too. Here's a bigger one. So again, this is gonna be straight from the river's edge. Now, I've also got a magnet. Let me get out this magnet. Look at that dirt right there. See where it's got the darker color? Now, I've got a big magnet. Pickle always wants to be in the picture. Oops, big magnet, just to prove that it does indeed work as a magnet. I've got just a bottle top, so you can see it is indeed a magnet. So what happens if I drop our magnet along the bottom? So if my bottle cap was down there, I'll put that down in there too. Make sure that we are indeed magnetic. Let's see what we pick up. Here's our bottle cap. So here we've got a bunch of iron. Iron is naturally magnetic. See how it's got the magnetic pattern going there. Now, why did I put my magnet inside a bag? Because you can't ever turn magnetism off. If I wanted to be able to clean my magnet again, I'd have to just sit there and shuffle and shuffle and shuffle. So this way, all I have to do is simply take my magnet out of the bag. Let's see if we can get our magnetite to drop down onto this container. Whoa, there we go. You see now, it doesn't have the pattern. I'll put my magnet back up here again though. See how strong, this is a super strong magnet. There we go, so now it's gonna stay. So we have magnets like this because usually when you're working around the lake, unfortunately, we do tend to drop tools and all down in the lake. Odds are that you're supposed to keep your keys and all safe, but sometimes accidents do happen. So that's why you always have a super strong magnet. So again, here at Lake Norman, we do have a lot of iron, that red clay kind of soil, and a little bit of magnetite in it. So get your own magnet. You can try this at home too. So
I just want to emphasize too, remember guys, we talked about soil is crushed rock plus organic matter. So magnetite is a mineral. And remember I said rocks are made up of minerals. So this is one of the minerals that came out, magnetite. Now magnetite is made up of two elements called iron and oxygen. Okay, iron oxide. And so when it, and a few other things. So when it breaks down, then it gets the iron ions into the soil, and then that's what some of the plants actually use. So it's, again, chemically complicated.
I just wanted to mention that that area has water covering it seasonally. So just like your seasonal wetlands at Tule Ponds, it's not the best location for plants to grow. It's an area that's got a lot of the silt and clay as well as just the sand. So when you were looking at that sample, you were seeing the large grains of sand. So as a soil scientist, I would make a soil card. And of course I would describe the location. I would say it was Mooresville, North Carolina. I would describe as much as I could about the topology, like I got it from the edge of the lake, that there was some vegetation, seasonal water. I would describe the sample itself, saying that it was sand grains, large in size and colors. I would be making, the colors were red, black, and clear. I'd also mention the freshwater clams. And again, just like the soil sample card that you saw before, you could take and kind of make a little mud slurry and place it actually on the card itself. Or you can even do something like this with a little bit of some tape, something like that. So again, you have record of it. So you want to record as much data as you can as far as that soil sample. All right. Just remember that with this basic rock, you have several other things. You've got climate, organisms, relief, where it is on the world, I guess, and the parent material, and time. It takes all of those things to make those rocks become soil. So it happens over a very long period of time. So there you see a good soil sample card where we've just kind of made a little muddy slur and it'll dry off. But then that gives you that, so you can again look at that under a hand lens or a microscope. And again, the soil that you're looking at in your own backyard is going to be different than what I have in North Carolina, or even what's different at Tule Ponds. It's all been, again, changed over time. Some mud, some of the dirt and the soil may have been brought in from other locations. It may have been turned over a lot. Again, all of those are factors that determine what that soil is. But that's why at Tule Ponds it was so important to plant native plants, because we know that those native plants would do well in that type of soil that we had there. We didn't need to change it to make it be any different. There's, again, plants that were adapted for that soil. And that goes the same everywhere.